5 amazing tensegrity structures. If you've been scouring the internet lately, then it's a given you've come across a few awesome and at times goofy videos of engineers creating all sorts of amazing physical systems. Enter the realm of tensegrity, where the weird but wonderful comes together effortlessly. Hello and welcome back to Top Tech. On this channel, we investigate the hidden technological processes that make modern life possible. Today, we'll be taking a look at tensegrity, not to mention some of the most amazing tensegrity structures currently making the rounds on the internet. But before we get started, don't forget to put your anti-gravity suits on, because you'll be hard-pressed to believe there is any gravity with some of the structures in this video. Hit that like button, subscribe to the channel, and push that notification bell as we send you to space and beyond. Because trust us when we say, it's going to be an amazing odyssey. What is tensegrity? You thought you'd seen it all. You thought you'd watched all the videos on the internet, then suddenly you come across some mad scientists slaving away in their secret basement to create something you've never seen before. A table that looks like it's floating on air. You, my friend, have just been tensegrited. In a world with so many mysteries and surprises, science and engineering are two subjects that seem to ground us back to reality. Or so you'd think. Yes, these subjects can be weird, so weird that some scientists like Elon Musk command a godlike reverence wherever they go because of their achievements. To the untrained eye, it can be hard to believe that a simple string can be made to support compressive loads nearly 3 to 4 times its own weight. Indeed, hasn't traditional science always taught us that weak always cracks under the pressure of strong? Remember, however, that physics has silent and subtle forces always working in the background that influence how a material behaves, and one of them is tensile strength. You'd be pleased to know that that's exactly how your classic crane works. It gets to a point, however, where a simple cord like a string can no longer support any compression on its own. That's when engineers decided to work to create a balancing system of components that can withstand a lot of compression. And alas, tensegrity was born. A spectacular visual of tension and integrity. Sounding a bit complex? Well, let's break it down for you. You see, tensegrity takes place when a structure experiences a form of floating compression due to the strength of the cords currently under tension caused by the suspended components. These cords, therefore, have the ability to support a system while it's under compression. Tensegrity can be fun. While a crane might not have the ability to support compressive loads on its own, it can be the secret to building a tensegrity structure. But how exactly? Take, for example, this amazing floating table right here. You can clearly see that the wood structures below make up a base that resembles a crane-like structure. These wood structures are then held together right in the middle as a result of tension that's coming from the middle string. The 3 strings attached to each corner of the base and top sections are added to provide extra stability to the structure. So, it's all about balancing the weight. The cord attached to the crane-like beams can only hold weight in one direction. Ideally, if we lived in a perfect world, the only force that should be acting on this system should be gravity. But that's not the case, is it? Having one string would create an unstable system, sort of like how unstable a pendulum is. Therefore, the other strings add stability to the system by altering the tension in accordance with the weight distribution. It's pretty amazing, right? Here's another example of a homemade tensegrity structure that really takes our breath away. This tensegrity floating table might be different in terms of the design and material used, but the principle is still the same. In this case, the engineer has used steel in place of wood and iron chains at the cords. As you can clearly see, the structure adheres to the same rules of tensegrity just as the wooden table. Mind you, the engineer in this case really took his time cutting the metal to precise measurements as well, and going the extra mile to make the table look like a badass torture device from a James Bond movie. But hey, if you don't have the mechanical and electrical power tools to build these 2 tensegrity tables at home, here's a simpler one you can go about making. All you need is a pair of needle nose pliers, some cable cutters, a steel cable, and bamboo legs, which are actually the most important element in the design process. You can start by cutting the wires of the steel cable and inserting them into the wood structures. This is to find the ideal tension to tighten the wires. In fact, this is a pretty cool DIY project you can do during these turbulent times. Real-life applications of Tensegrity. While making a Tensegrity table might be a fun project to do at home, this science actually has a lot of application in the civil and architectural engineering sector. Engineers that design Tensegrity structures are the real-life Tony Starks of our world. Some of them are the masterminds behind the most breathtaking structures around, from stadiums to bridges and even space exploration equipment. Take, for example, the Kurilpa Bridge in Brisbane, Australia. This is, in fact, the world's largest Tensegrity bridge, which was opened on the 4th of October 2009. The bridge itself can be classified as a cable stay structure. It's built on the principle of Tensegrity to create a balance between tension and compression components, resulting in a light but strong bridge. The bridge is roughly 470 meters long with a width of 120 meters. It's endowed with ample relaxation and viewing platforms, 2 resting areas, and a continuous all-weather canopy that spans the entire length of the bridge. This canopy is then supported by a secondary Tensegrity structure, putting the total estimated weight of the bridge at 550 tons of structural steel, including 6.8 kilometers of spiral strand cable that is incorporated into the bridge. What a marvel! Tensegrity is the future of smart building. For years, the static nature of buildings has always troubled our civil engineers in the city. They had to find a way to factor in the changing demands in the building, such as the load and temperature variations that occur throughout the day. Over time, these changes would result in severe damages to the building, costing the real estate company millions of dollars in repairs. So, how could they solve this problem once and for all? Thanks to the application of Tensegrity in structures, buildings can now adapt and improve to changing responses in the environment that result in compression of the elements. Which means that buildings like your average skyscraper can remain grounded for decades without as much as a fault in its beams. Deep space exploration. While many smart structures are being employed in buildings today, the concept of Tensegrity has also found its way into deep space exploration. Yes, robots generally tend to be fragile. Sure, there are industrial robots out there that can handle the toughest of environments, but that's mostly when they remain in a factory setting and are serviced regularly. But what about probe robots, like the Curiosity rover, that have remained in space for more than a decade? Tensegrity robots, like their architectural counterparts, take advantage of tensile materials to improve their structural integrity. Normally, that comes in the form of rigid struts that are held in shape with high tensile cables. And that is exactly the case with the Super Ball V2, which can withstand falls and impacts pretty well. The Super Ball V2 was constructed by researchers at the NASA Ames Research Center in collaboration with the University of California, San Diego Coordinated Robotics Lab. It was crafted from 6 metal bars, with each pair dedicated to each axis. The metal bars are about 2 meters long each and are connected by the cables. The cables are wound on motorized spools, which can then be used to collapse the robot as well as to enhance locomotion. But aside from this, the most impressive aspect of the Super Ball V2 is its uncanny ability to withstand tough impacts. This nifty structure here can absorb a massive 3 to 4 meter drop and can even take a tumble down a rocky hill. Such capabilities can make it the ideal structure to handle the most rugged environments, especially for space exploration to other planets where maintenance by humans will become an impossibility. That being said, it's crystal clear that Tensegrity's benefits are endless. For example, the use of the Tensegrity technique can result in small adjustments for the fine-tuning of loaded structures. In other words, adjustment of a damaged structure can be made to automatically repair it while still in service. Such structures that will have this ability will be an important feature of the next generation mechanical structures, especially civil engineering structures. For example, a portable bridge or a power transmission tower can be transformed into a Tensegrity structure that can be manufactured directly in the factory then moved to the site. This will not only save on the material expenditure, transportation costs, but also eliminate the need for having laborers to carry out the installation. And lastly, as we had mentioned earlier, the use of Tensegrity in buildings will enhance the performance of a building to support more load and adapt to shifts in the environment. However, for us to truly benefit from the beauty of Tensegrity, it is essential that we factor in the right choice of materials, the geometry, as well as the electrical, thermal and mechanical components of the material critical to the control structure. And that's all she wrote, folks. So let us know in the comment section down below if you'd like a Tensegrity piece of furniture in your place. Once again, thanks for watching and don't forget to subscribe to the channel and leave a like on this video.